let's introduce our next talk here. He's mostly known for winning the Kahoot. That's his primary claim to fame. But on the side, when he's not winning Kahoots at Utah.js, CJ Reynolds is a software developer, educator, and maker. He is a co-organizer for the DenverScript meetup, makes videos for syntax, and streams himself teaching and coding on the Twitch and YouTube channel Coding Garden. CJ's talk is titled Blazing Fast Vue.js with Vapor Node. Please welcome CJ Reynolds.
Thank you for that great introduction. And as was mentioned, we're talking about blazing fast Vue.js with Vapor mode. And this is a Vue talk, but if you're not a Vue dev, you're still in for a treat. We're going to be talking about some other stuff too. So pretty much all of front-end development these days lies on top of a single concept. V equals f of s, or the Vue is a function of state, otherwise known as declarative UI, right? So when we write our components, we can write them in a way that is declarative, right? This Vue component here just says, render out the title in that H3. If the input ever changes, update the title behind the scenes, and the Vue is going to automatically update. So this is declarative UI. This is a Vue as a function of state. And as Vue.js developers, this is all we have to do. We don't have to worry about the nitty-gritty details of what's happening behind the scenes to actually update this on the web page itself. And when you write code like this in Vue.js, that template function, or that template element you have there, actually gets compiled into a virtual DOM render function. You may not have realized that because you don't really need to know that, but ultimately that actually is very similar to writing React code. So for all my React coders in the audience, you do get some React code in this talk, even though it's about Vue. But basically, this is declarative, right? You write some code that talks about your state, shows how it should render out, and we have working websites. And really the way this works is at compile time. So when you run npm run build or npm run build, it takes that template that you wrote and turns it into a virtual DOM render function. If you're writing React, there's a little bit less of a transformation because all of those JSX tags just get turned into create node calls, but your Vue template gets turned into some very similar code as well. But what that means is when your code is actually running in the browser, it goes through this whole process where anytime there's a state update, so if you imagine the example I showed you, let's say that title gets updated, we have to go through this process of first rendering out a virtual DOM tree. We then take that new tree, compare it against the old tree, and figure out what actually changed. In this case, title might have changed. And we then, that whole process is called the VDOM reconciliation algorithm. And after all of that, then we finally go and update the DOM with what has happened based on what the user did. So I want you all to be honest. How many of you have ever said, the VDOM is fast, when you were talking to like a coworker or something like that? Yeah, you probably said it. But my question is, faster than what, right? It's definitely faster than replacing an entire DOM tree, right? So it's faster than literally saying element.innerHTML equals a whole new string of HTML, right? And that's why we don't write code like this. That's why we have a framework that can handle those piecemeal updates via the virtual DOM, because this is really slow. If you ran this in a browser, it has to repaint that entire element. So the virtual DOM is faster than this, definitely, but it's not faster and will never be faster than just direct DOM updates, right? So writing code that directly sets text content on an element or directly sets an attribute, that code is as fast as you can get. It's the lowest level of abstraction we have when building out user interfaces for a web browser. So the virtual DOM is never going to be faster than this. And if you look at that flow of state update, VDOM render, VDOM reconciliation, and then DOM update, wouldn't it be great if we just cut out the middleman and went from whenever there was a state update, we instantly had a DOM update? This, my friends, is Vue.js Vapor mode, and it's what we're talking about today. So hello, nice to see you. My name is CJ. I am a senior creator at a place called Syntax, and every episode of Syntax and video of Syntax is brought to you by Sentry, an error monitoring company. So who here listens to the Syntax podcast? Nice. Who here watches the YouTube channel? Nice. Love to hear it. So if you want to learn more, syntax.fm, sentry.io. I also have my own thing called Coding Garden, which I'm kind of neglecting since I started at Syntax. So there's some weeds in the garden, but here's where I got my start, live streaming on YouTube and Twitch, and basically doing like full stack builds and talking through my process. So you can learn more at coding.garden. Now let's figure out who all of you are. And because this is a Vue talk, I assume there's some people here that write Vue. So who writes Vue on a daily basis? Okay, probably like 40, 50% of the crowd. Great, glad to see you here. Any React devs in the crowd? Okay, probably the other 30, 40%, which makes sense. We're at a JavaScript conference, and React is kind of dominant. Any Preact devs? Got one? Yeah? What about Angular? Yes, cool. Any Svelte devs? One. Any Solid devs? For the record, no hand is raised, so there are no Solid devs in here. Any HTMX developers? There's a few, cool. Before we dive into Vapor mode and how Vue.js is doing rendering these days, I want to do a quick history and talk about how rendering has happened throughout the front-end landscape, starting in 2010 with Angular. There was front-end developers before 2010, but this is where we're starting. And when AngularJS came out, it had two-way data binding and did dirty checking and had a digest loop. So essentially, behind the scenes, there was a polling mechanism that was checking to see, are there state changes, are there state changes, are there state changes? And if there were, then it would update the DOM. And that worked. It wasn't ideal, but it worked for what it was. And then in 2013, React came out, and it brought the virtual DOM, which we kind of talked about at the beginning. Basically, you write code that produces virtual DOM trees, and then behind the scenes, those get diffed to actually update the UI. In 2014, Vue.js was released, and Vue.js version 1 actually did direct DOM manipulation with reactive data binding. So they were like 10, 11 years ahead of their time, because in version 1, that's actually how it worked. But in 2016, they released version 2, and they actually switched to a virtual DOM. The reason being, VDOM works much better if you're trying to do things like server-side rendering, if you're trying to handle like asynchronous code, and ultimately if you want to write lower-level templates. Because with the introduction of using the virtual DOM in V2, you could actually write Vue components with JSX. And that was enabled because it was built on top of a virtual DOM. In 2016, Angular version 2 was released, and it brought ahead-of-time compilation with change detection. So it was one of the first frameworks to basically highly optimize the output code, and then the runtime itself was really just checking for changes, and then that highly optimized code would update the DOM directly. So even Angular was pretty ahead of its time as well. And around the same time in 2016, that's when Svelte came out, and they kind of popularized this idea of like ahead-of-time compilation. They were known as the disappearing UI framework, and basically it was they have a compiler that went directly to DOM code. There was no runtime code. And this was a revolutionary idea at the time. But basically, you could write declarative code that is nice to use and easy. But at the end of the day, the code that you're shipping is as minimal as possible and all that's required to actually update the UIs. In 2018, Solid.js came out. And it was kind of a hybrid mode, but they learned a lot from Svelte. So Svelte kind of proved that you didn't really need a virtual DOM to do this kind of thing. And Solid.js actually allows you to write JSX, and it does direct DOM updates. So for any React developer out there, Solid.js is probably the closest thing that you might like to take a look at that does things in this more optimal way, where instead of having a virtual DOM tree, it uses signals. So there is still a little bit of runtime code to keep track of the data that's changing, and ultimately it has fine-grained reactivity. So instead of entire virtual DOM diffs, instead it's targeting and updating specific elements as the user is interacting with your app and as state is changing. In 2020, Vue.js v3 was released, and this brought compiler-informed virtual DOM. So Vue.js actually has one of the fastest virtual DOM implementations, and that's because they do smart things ahead of time. So when you run npm run build, it actually adds hints in the compiled code and extracts things out that don't necessarily need to be part of your virtual DOM render function. So v3 of Vue has a really fast virtual DOM implementation. So this is the landscape. Here's how everyone is doing things. And soon, very, very soon, Vue.js is going to be releasing version 3.6, which brings us Vapor mode. And it's kind of a culmination of all these ideas that have been floating around the front-end ecosystem and been brought into Vue.js itself. And so I've been using Vue.js since 2016 or so. And in the early days of Vue, when I was teaching it and telling people about it, I always said, and people would say once they saw it, it kind of looked like the combination of React and Angular.js. Not Angular 2 yet, but the old Angular with all the ng directives and everything. When you looked at Vue.js, it was like, oh, it's very familiar. There's a v-for and a v-if, very similar to what was in Angular, but it's using a virtual DOM. So in the early days, Vue was like the baby that was had by React and Angular. And today, it's like, take that baby that React and Angular had, and then let's say there was another baby that was made by Svelte and Solid, and then they somehow found each other and had a baby. This would give you Vue.js Vapor mode. And so it's really taking all the best of the ideas of how everyone is rendering stuff and creating a highly optimized and performant way of rendering out apps. So you might be wondering, why do we need performant rendering? Ultimately, it's for highly interactive UIs. So let's say you have dashboards, you have charts, anything that's really changing in the UI very often. Maybe data tables or like massive lists of data. Really anything that's just constantly updating. That's when you need to care about rendering, and that's when something like the virtual DOM might actually break down. So with Vapor mode, it's coming in version 3.6. It's currently in alpha. And essentially, you can write the exact same code as you're writing today, but it's going to have a different output. So instead of outputting code that is virtual DOM code, it's going to output code that is highly performant without the virtual DOM runtime that can directly update the UI. It uses the exact same API, but you're going to get better performance and less memory usage. And it's compatible with existing code bases. So how fast is it? Very, very fast. So this is a very popular benchmark that's on GitHub. It's called JS Framework Benchmark. And I have the latest benchmark results here. We want this one, so I don't blind you all. But I filtered it down to just show us Vue with Vapor mode, Svelte, Solid, Vue without Vapor mode, Preact, and React, and Angular. And you can see that Vue Vapor is even faster than Svelte compiled code. So this benchmark, essentially, it's an app that creates thousands of rows and then deletes the rows and then updates the rows again and does it multiple times and keeps track of average time taken to do all of those things. And you get an overall score, which is the weighted geometric mean in terms of how performant that particular framework is. And Vue with Vapor mode is just slightly slower than vanilla.js. So these are exciting times. Basically, you're going to be able to write the exact same Vue code and output code that is just as fast, almost just as fast as vanilla.js. So how small is it? In looking at just like a hello world, the virtual DOM bundled size is about 22.8 kilobytes. And with Vapor mode, it's about 8 kilobytes. So that's about a 65% reduction just by using Vapor mode. And how do you use it? Very simple. So look at that same Vue component that we wrote earlier. We literally just add the Vapor directive to the script tag. And that is a signal to the Vue compiler that when it sees this component, instead of compiling it into having the virtual DOM runtime, it's going to compile it to use Vapor mode instead. And one of the nice things about how they're introducing it and how it works is you can actually have a combination of components in your application. So you can have components that are based on virtual DOM and using the standard way. You can have components that use Vapor mode. You can even nest virtual DOM components inside of Vapor components. So they've really thought about the architecture of this and are really thinking about how to allow for gradual adoption as they introduce this new rendering mode. Similar to opting in for a single component, you can also opt in your entire application. So instead of saying create app, you can say create Vapor app. And now all of your components are Vapor mode by default. So yeah, that's Vapor mode. It's pretty slick. Let's look at some of the output. So this playground, play.vuejs.org, allows you to put in some Vue single file components, and you can actually look at the compiled output. So I have an example here. Basically this hello world that I was showing you. So we have a ref that holds on to the state. We bind the message there, and then whenever we type into the input, that should update the state. Okay, so that's our component. this JS tab will let you look at the output. And if you want to try this, you want to make sure in the dropdown you select 3.6.0 Alpha 2. So the Alpha is the one that actually has Vapor mode inside of it. And that will then allow you to put the Vapor keyword here. But before we look at it with Vapor, we can look at the compilation output without it. So what you're looking at on the right-hand side is basically what gets created when you type npm run build in your Vue app. And this template right here gets turned into a render function. And if you've ever looked at like React code that wasn't JSX, it's somewhat similar. So we have functions for creating nodes like h1 or creating element nodes like input. And then we can pass in callbacks here. This handles setting up the callback to actually update the state behind the scenes. But this render function here is what got created by writing this template code here. So this is how Vue.js works today. But if I put the Vapor keyword on there, you will see things actually get a little bit simpler and somewhat easier to read. So with Vapor mode, now this component is using a few other functions. So it's using the template function for each of the elements, and then it's created a render, and then there's a couple of functions that are basically the Vapor runtime. So there's like apply text node and render effect. And so one of the things to note is if you look at that output without Vapor mode, all of these imports here are coming from Vue.js. And so this is essentially the virtual DOM runtime. This is what we have to import when we have a regular plain old Vue app. But when we are using Vapor mode, the number of imports becomes way less, almost cut in half. And so that's really why we're reducing our bundle sizes, is that outputted built component no longer needs all that extra virtual DOM stuff. So I highly recommend check out the playground, plug your components in, and kind of compare the output, and you can see how all of that's working behind the scenes. So you might be wondering, what's the catch? It only supports and will only support the composition API and script setup. So anybody that was around during the transition from Vue 2 to Vue 3 knows there were a lot of pains around trying to get people to use the composition API and coming across maybe code bases or libraries that weren't converted yet. But for technical reasons, but I think also for reasons to make sure that we have a more standardized way of doing things, you can only use Vapor mode with script setup and the composition API. Like I mentioned, it's currently in alpha, but they're working fast and working hard. And when version 3.6 is released, all of these features will be experimental. And on that same note of not a fiasco, but things weren't great in the transition from Vue 2 to Vue 3, but you'll notice we're not getting a major bump here. We're not going from version 3 to version 4. All of these features in Vapor mode are going to be available in 3.6. So this is kind of a signal from the creators of Vue.js and maintainers that, hey, we want this to be gradual adoption. We don't want to break stuff. And we want you to be able to use this stuff in your apps without needing to do like a full migration and upgrade to like version 4. When it's initially released, you will not be able to do SSR, transitions, keep alive, or suspense, but it will support those things eventually. And I'll show you the roadmap in a second. There are open PRs that are actually working on getting all of this stuff working with Vapor mode. And ultimately, they want it to be a slow transition so they can get community feedback. You can try it in your apps. You can tell them what breaks. And initially, depending on if you're not doing anything too crazy, you can start getting much more performant apps. If you want to try it today, just do a npm install of Vue at 3.6.0-alpha.2. You can check out npm to see if there's any alphas released since now, because right now alpha 2 is the latest one. But literally just install it, and then you'll get access to importing create Vapor app, and also get access to adding that Vapor attribute to your Vue components. So looking ahead, you can check out the roadmap. So there is a GitHub issue on the Vue core repo that is the roadmap for Vapor. So you can see all of the core features that they plan to support and all of the open PRs that you also could potentially comment on. So if you're trying to use some of these features in your app and maybe something breaks, you can let them know. But you can see all of the work that they're doing. And this is real. It's really happening. It's not just vaporware, it's legit. And in the issue, you can also see that they care about the ecosystem. So they care about making sure that all of this stuff works with Vue Router and Pina and Nux for SSR hydration and everything else. So that's Vapor Mode. I encourage you, go forth, build, install the alpha, try it out, and thank you very much.